In this video, we'll be going over Goal 2 of Week 2 CAD Guide. We're going to be focusing on the Robocup part in this video. If you missed Goal 1, where we made a V-belt and are looking for guidance on that, just go over to the previous video and you should be able to find it there. So let's get started. In this video, we're going to be talking a lot about radial symmetry. It's going to come a lot in handy when we're wanting to create patterns that are around an axis instead of around a square or just mirroring things. So we're going to be working a lot of different concepts in this video. So you may have noticed that in this previous slide we talked about using different units. Now I could type in the unit every time I wanted to create a dimension, or I can change the base unit in Inventor. So I can see that I've got this part open, and so we go up to the Tools tab and go to Document Settings, and then over to this second tab is Units, and we can change from inch to millimeter. And this can be useful for when we're creating DXF drawings for the water jet or for the 3D printer. It can be useful to have different units. But remember, you can always type them in. Another thing to note is that when we're using the document settings, it's only going to be for this current part. So if I open up a new part, the change of units won't carry over. So you have to remember to make the change every time if you want to have it. So now we're going to start with a basic extrusion, and by now this should be pretty easy. It's just a simple circle with a diameter of 50 millimeters. And then a height of 8.5 millimeters. And now we're going to make a hole. So the thing with holes is we don't want to necessarily just create a circle and then extrude it cut. We want to use the hole feature. And we could use a circle for that, but it limits us. So instead what we're going to do is we're going to start a sketch. And we're actually going to use the point, which is right over here. And we'll put it smack dab in the center. And we go ahead and finish. And then when we use the hole feature, it'll automatically select this point that we made. And so now you can see we have a ton of options of the different holes that we can make. So we're going to make a simple hole, which means there are no kind of tapping in it. It doesn't have a seat, and then we're going to terminate it at a distance. It may default to through all, but we're going to change it to a specific distance. And we'll make it a 5 millimeter depth and a diameter of 5/8 inches. So I gotta make sure I include inches in this dimension. And as you could see, it changed the size pretty dramatically. So now we're gonna make another hole on the other side. And keep in mind, this is not necessarily how we wanna make holes, but it's just another option of showing you what you can do with Inventor. So we're gonna be using Project Geometry to take that cut that we made, and now we can reference it as if it's on this sketch. So I'm just going to make a hole. Let's see here. Make a hole right off to the side, it doesn't matter where. And we'll make it a diameter of 0.475 inches. And then to constrain it, we can use this Concentric Circles constraint up here. So this is the one I want to move here. And just like that, it does it for me. And since this projected geometry is fixed, it knows which one to move. If neither of the circles are constrained, it can be a little unpredictable which one will move and which one won't. So I want to point out that this isn't great CAD practice, because if I ever changed this other hole, things might break. But for now, since I know that this is what the part is going to look like, this will work for now. I just wanted to show you the concentric constraint and another use of project geometry. So we'll go ahead and finish this sketch. And then we're going to do the extrude cut with this inner circle. And it can go all the way through. So a distance of 8.5 gets the job done. I could also do the through all. It doesn't matter as long as it gets all the way through. And so this is a counter bore of sorts, but we're going to cover exactly what a counter bore is next week, and the whole tool that we can use to do that. So now we're going to make another sketch, and so we're going to go over to this first circle that we made and create a sketch. And then let's go back to rectangles, and we're going to do, let's see here, it wants us to do the 3-point center rectangle. And so if you're not sure the order to click the 3 points, then if you just hover over it, it'll tell you exactly what to do. And so we'll go ahead and create this rectangle. And so even though it looks like I'm only going over to the right side, it's actually extending in both directions. And so I can specify that I'm going to want it in 0.52 inches, and then a total height of 0.125 inches. And then the same thing here. It's going to be going straight up with a height of, let's see here, 0.27 inches. And then because my document is in millimeters, I have to specify this inches every time. And then 0.135 inches. And then you'll see that it's all purple because I haven't fully constrained myself. There are a couple things that I need to fix first. The first is the distance between the edge of the circle and the edge of my rectangle, and that's going to be 0.1085 inches. You might be thinking, that's extremely specific, and why would we need to be that specific? Well, sometimes with machine parts, things have to be really minute with details, because if we're going to be producing them with really specific machines, then we can achieve that level of detail, and it's worth paying attention to. But you'll see that we still have some constraints missing, and that's because I can probably move it up and down. So here's what we'll do. We have to constrain the center to the horizontal axis. So you'll see that we can constrain the center to this axis, and all of a sudden it turns all black, and we know that we're fully constrained, as we can see in the bottom right over here. So now that we've finished that, we can go ahead and create some features. And so we're going to extrude cut this long rectangle. And I could have selected all the different little cuts, but if I hover over in the right spot, then I can select the whole thing in one go. And we want to go all the way through. Okay. Now the second cut I want to make with the same sketch. But as you can see, the sketch disappeared. And so to make it visible again, all we have to do is right-click the sketch and add visibility. And now we can interact with it again. So I can choose this rectangle here and make another cut, except this time it's going to be 0.13 inches. And then, for simplicity, we're going to make this invisible again. And we can see that we have our two cuts exactly as we want them. So now we're going to be using some fillets. And we'll select our two edges here, and you'll see that because the size is wrong, the fillets aren't possible without creating this little semicircle here. So we have to edit the size to 0.055 inches. And then we're going to do 4 other fillets. And remember that if you click the wrong edge, there's no way to deselect fillets, so you just have to start over. Hopefully you don't have to deal with very many edges at the same time though. So go ahead and click these, and just so you know, you can select through solid features, you just have to be very careful. So we'll go 1/32 inches. So we want to use fillets for a couple reasons. We know that there's not going to be much load on these wheels, but we also know that when we're going to be using a mill, which we'll be going over in a couple weeks, the end mills are round. And so when we're cutting things with those mills, it's way easier to get rounded corners than sharp corners, unless it's on the outside. But even then, it's very difficult. If we're going to be wanting really sharp corners, then we're going to have to use a different machine, which I don't believe we just have in the shop. And it's very expensive to get that done. So we just stick to filleted corners. So now we're actually going to be doing the radial symmetry, because I don't think you guys want to do this, let's see here, 15 more times. So we're going to use the radial symmetry pattern. So if you go over in the pattern box over here, you'll see that there's a circular one. And we'll select all the features that we drew over in this shape here. And I accidentally selected the main circle, but since we're going to be rotating about this axis, then it doesn't matter too much, so we selected that it's going to be 360 degrees and it defaults to that. Instead of 6, which is the default, we want to make 16. So it'll take a second, and then all of a sudden, boom, it's done. Except we have a small issue here. Let's see here, what happened? Oh, you know what? Selecting the whole circle was an issue, so we have to delete that and start all over. So you have to be very specific with what we select. And then for the rotation axis, we don't need a specific axis. We can select just a circle, and it'll select that axis. And this time, we have exactly what we want. So just to go a little more into the circular pattern, you have to choose a feature, and then the axis that we'll be rotating about, and the number of instances over the specific angle. So if I had selected a different angle, such as 270 degrees, and I still wanted 16, then they would be evenly spaced around that angle, and I would be having a whole chunk left blank. Of course, you have to keep in mind if all those features will fit, because if you put in too many, then they'll overlap, and the cut will look really awkward. So now I'm going to show you, it's not necessary, but I'm going to show you how to use it. So we've used work planes in the past, but we can use work axes as well. And so all I have to do is just select a circle here, and it'll automatically place this axis in the center of it. And so we can use this for further constraints instead of selecting just the circles. Again, it's not necessary, but it's a helpful tool to know about. So let's do some more patterns, all right? We're going to start a sketch. I'll start it on this other side. And it will be a point on this axis. And I'll give it a dimension of 0.45 inches. And if you've noticed, we've been using a lot of inch metrics, or inch dimensions, so that if you really wanted to change it back, it won't mess up the rest of the part, because it'll simply transfer the unlabeled to what they were. It'll take the dimensions that already exist and convert them accordingly. So don't be afraid of changing your units in the middle of a part. So we want to make sure that this point isn't actually fully constrained, because even though it's assuming I'm placing it on the axis, it doesn't know that for sure. And so we'll go ahead and make it easier on the computer. Now we're fully constrained. And then we're going to make this clearance hole. And when we say clearance hole, it means it goes all the way through. So it'll be through all. and a diameter of 0.125 inches. So again, I could have projected geometry, I could have used this work axis, but as you can see, I just referenced to the origin of the axes. Okay, so now that I have my hole, I can make another pattern. So we'll go ahead and select the feature. And then the rotation axis. For this, I'll select my work axis and then make it 3. And we're almost there. We just have 4 more holes to make. So 1 with a rotation symmetry. So we're going to go ahead and make another sketch on this side. And because it's going to be at an angle, it's nothing that we can snap to. And we want to be careful we don't want to snap to any of these other geometries on the wrong side. So what I'm going to do is I'm going to use a line. And when I go out, I can specify the length, which will be 0.875 inches. And then I'll tab over to the degrees and then make it 11.25 degrees. And then to avoid confusing myself, I will right click this line and make it a construction line. Now I can put a point and just smack it on the edge of there, and you'll see that it's considered constrained because I fully constrained this line and then snapped at the end of it. So one more time, we'll make it a hole, just a simple hole, but with a distance of, we'll make it 4.5 millimeters. So it doesn't go all the way through. And I accidentally made it the wrong diameter, so I'll right click this feature in the feature tree, and then I'll do edit feature, and I can change the diameter to the correct 0.11 inches. 0.112. And then finally, the circular pattern, just as before. And then this time, 4 holes. Congratulations, you've made an actual RoboJackets part. And it looks pretty complex, but as you can see, it's just a lot of features we already knew, plus some very simple features and tools that you learned that make things way easier. So hopefully you learned something. If you have any questions, go ahead and go to the Piazza or email one of your instructors, and we'll do our best to help you out. See you next week.